Hello everyone, this is Teacher Michelle and welcome to another episode of Unang Math. In this episode, I will be covering this lesson about the properties of an isosceles triangle. Okay, let's start by defining isosceles triangle. Isosceles triangle is a triangle with two sides of equal length. Okay, example. If this is an isosceles triangle, so this is triangle ABC. This side is equal to this side. So we have side AB or segment AB and segment AC. These two sides are equal in length. So when you see a triangle that has two equal sides, then that means the triangle is an isosceles triangle. Isosceles triangle has what we call vertex angle, base, and base angles. Vertex angle refers to the angle formed where the two sides of equal length meet. In this isosceles triangle, these are the two sides that are equal in length. They meet at this point, so there is an angle formed here. So this is the vertex angle. How about the base? Base is the side opposite the vertex angle. If this is our vertex angle, the side opposite to this vertex angle is this side BC or segment BC. So segment BC is the base of this isosceles triangle. Okay, how about the base angles? Base angles are the two angles adjacent to the base. If this is our base, two angles adjacent to this base are these angles. So this angle ABC and angle ACB are the base angles of this isosceles triangle. Okay, now that you know these important terms about isosceles triangle, let's now move on to the two important properties of an isosceles triangle. Okay, the first property is the two base angles of an isosceles triangle are equal in measure. Let me explain why the two base angles are equal in measure. If this is our isosceles triangle, as you can see, this side is equal to this side. So it means this is our vertex angle. Opposite the vertex angle is the base. So segment BC is our base. The two non-adjacent angles are these angles. And according to the first property, these two base angles are equal in measure. Okay, why equal in measure? If we will consider this angle bisector or this bisector, it bisects this triangle into two congruent triangles. So let's say this is D. So we have triangle ABD, this triangle. So triangle ABD. And we also have this triangle ACD. So triangle ACD. And these two triangles are congruent. This side of this triangle corresponds to this side. They are equal in measure. This is a common side. So this angle corresponds to this angle. It means they are equal also in measure. So these angles are also corresponding angles and they are equal in measure. So this congruence is SAS congruence. So this proves why the two base angles are equal in measure. Moving on to our second property. According to this one, the angle bisector of the vertex angle in an isosceles triangle perpendicularly bisects the base. Okay, I will explain why the angle bisector perpendicularly bisects the base. Okay, if this is our isosceles triangle, this is our angle bisector. Okay, again, this bisector bisects this triangle into two congruent triangles. So we have this triangle, triangle A, B. Okay, let's say this is B, so A, B, D. And this triangle, triangle A, C, D. So triangle A, C, D. These two triangles are congruent. Okay, this side is equal to this side because these are corresponding sides. This is the common side. So this angle and this angle are corresponding angles and they are equal in measure. These angles or these two angles are our base angles and they are equal in measure. Okay, this angle and this angle are corresponding angles. So it means they are also equal in measure. This segment BC, or the base of this isosceles triangle, is a straight line. And we know that straight line measures 180 degrees. So it means each angle measures 90 degrees because 90 plus 90, that's equal to 180 degrees. That's why this bisector, angle bisector, perpendicularly bisects the base because these two straight lines form 90 degrees angle. Okay, so we can say that this line AD or segment AD is perpendicular to segment BC. Okay, the symbol for perpendicularity is this symbol. So we read this one as segment AD is perpendicular to segment BC. So it means segment BD, so we have segment BD or this measure is equal to this measure. So this is segment CD. So segment BD is equal to segment CD. Okay, now that you know the important or the two important properties of an isosceles triangle, you have to remember and you have to understand these two properties because in our next episode, we will be solving some questions or problems about isosceles triangle.